Hi everyone, I want to welcome you to another section, and in this particular video I'm talking about different kind of inhibitions that we have as touching enzyme kinetics, which basically we have reversible inhibitions and we have irreversible inhibitions. But for the sake of this video, I'm going to be focusing on the reversible ones. And there are three types of reversible inhibitions, which includes the competitive, the non-competitive, and the uncompetitive inhibition. So I'm going to be describing to us these three types of inhibition under the reversible inhibitions. At the same time, their graphs and their kinetic parameters when we are given any question pertaining to any one of them, how to go about it. So basically, the line Weaverburg plot for each of these type of inhibition differs. So, and I'm going to start from that point by showing us um, the different graph for this different set of these different types of what of inhibition. So first, for competitive inhibition, the graph of the competitive inhibition looks thus. So you have a line like this and you have a line like this. So in this case now, you have this is the graph of this is the line graph forward for inhibition. That's where you have inhibition. This is where you have no inhibitor. So this one is for the kinetics of an enzymatic reaction with inhibition. This one is for no inhibition, and you are plotting 1 over V against 1 over S. So in this case, you can see something notable, the fact that the y-intercept of the two graph of the two lines are the same. That's a what? A competitive. This is competitive. This competitive inhibition. For the uncompetitive inhibition, we also have 1 over V against 1 over substrate concentration. This. So when you plot the graph of this, the line the both for the one for the reaction that contains inhibitor and for the one that does not contain inhibitor. So in this case, you are going to have something of this nature, and at the same time you have this. Now if you look at this, in this case now, let's say this for inhibition and this for no inhibitor. So now this one, the two lines you can see here now, they have different y-intercept but the same slope. The slope is somehow is the same. So this is for an uncompetitive inhibition. This is when you have an uncompetitive inhibitor. So that's for uncompetitive. For the last one, which is the non-competitive inhibition, in that case you are having a graph like this. The same thing, you're also plotting 1 over V against 1 over substrate concentration. So if you do that also, in this case you are going to have something like this. At the same time you have something like this. Now if you look at these two graphs, it's different from what I have here. These two that we have here, they are not having the same slope. At the same time, they are not having the same intercept. So this, let's say this for inhibition and this is for no inhibitor. So in this case, this is our non-competitive, this for non-competitive inhibition. For non-competitive inhibition. So one thing you must take note is that when they give you table of values that contains the velocity of enzymatic reaction, both for the one that contains inhibition and the ones that do not contain inhibitor. So at different substrate concentration, you can easily plot the line graph of the two given data on the same x and y axis like this. So you can see that here we have 1 over V against 1 over S of the one that has of the reaction that has no inhibitor, and this 1 over V against 1 over S of the one that has inhibition. So at the same time we have this and we have this. So based on how the how your graphs looks like at the end after you have plotted them, will determine whether you're having a competitive inhibition, or whether you're having an uncompetitive inhibition, or whether you're having a what, a non-competitive inhibition. So this is uncompetitive inhibition. So, and that's how to make a difference between these three. But like I said, there are some things that you must look out for. In this first one that we have here, you can see that the y-intercepts for the two lines that we have here is the same. The two of them have the same what, the same y-intercept, but their slope is different. So that implies something about competitive inhibition. In this case now, the slope is different. The lines have the same slope but different y-intercept. This one also have different implications, which I'm going to talk about. And for this non-competitive inhibition, there is different slope and different y-intercepts. So this one also have implications on the kinetic parameters, which is majorly your Km at the same time your Vmax. I'm going to talk about how each of them, what makes a difference between each of them. Now, for each of these type of inhibition, you can always get the Km and the Vmax. You can always get the Km and the Vmax, one for the inhibitor, the ones that represent the inhibition, and one for the ones that have no inhibition. So let's just try to look at this. So inhibition type, let me write that. So this is let's say this is the graph of no inhibition, no high, and this is the graph. So for the graph of, what's it called now, for the graph of inhibitor, let's, for the one that contains inhibitor. So I'm going to be working on this particular table to show us different things that we can have in this case. Now, in terms of Km and what's it called now, and in terms of Km, at the same time the Vmax basically. So I'm going to be talking about those two things. So let's start with competitive. For competitive inhibition, now for a competitive inhibition, the what's it called now, the Vmax, normally how to if you from the previous video you can check how to get the Vmax and the Km for underlying Reversible plots. So the K, you can get the Km and the Vmax for this line graph that has no inhibition. So let's say the Km there is this, the Km for no inhibition, and this is the Vmax. Now for this one too, for this second line that indicates the reaction with with inhibition, the Vmax that you got for this one will also be the same thing as the Vmax. So the Vmax here will also be the same. The Vmax that you have here will be the same, but the Km will be will be different. So let me put Km high. Permit me. So you are going to have Km high. You are going to have Km high, and you're going to have Km. So the Km that you will get for this line will be different from the Km you are going to get for this line because of the difference in in slope. But the Vmax you get for this will also be the Vmax value under this particular second line. And that's for what? For a competitive. So in a competitive inhibition, you are having different Km, and you are having the same Vmax. So the Vmax for this line is the same as the Vmax for this line, but the Km from this line will be different from the Km for this line. So please, let's take note of that. I would try to show us the difference between those two Km later, how that the Km for this inhibition will be more compared to the Km for this one that has no inhibition. Okay, now for uncompetitive, uncompetitive inhibition, permit me, uncompetitive inhibition. Now in this case now, both the Km at the same time the Vmax is what is different. So here if I have Km for no what for no if the if I have Km for this what for this no inhibition, and I have the Vmax for what for no inhibition. So because I've said there will be difference in the two, so that means that this one will be Km high, and I'm going to have Vmax high. So now the Vmax you are going to get from this line will be different from the Vmax you are going to get in this line, because one, they are having different y-intercept. At the same time, the Km you are going to get here will be different from the Km you are going to get for this line, which are, so you are going to have those two difference for an uncompetitive inhibition. And the last one, which is for non-competitive inhibition, for non-competitive competitive inhibition, permit me to write it this way. For non-competitive inhibition, in this case, you are going to, now this is the graph for non-competitive, like I said. Now they have different slope and different y-intercept, but the basic thing about the non-competitive is that the Km will be the same. The Km in this case will be what will be the same, but the Vmax will be different. So here, if this is the Km for what for no inhibition, and I have the Vmax for what's it called now? So this two will be for this. You are going to get a Km for this and a Vmax from this line. So, but for the one that contains inhibition, now like I said, the Km you got for the first one will also be this that you got here will also be the same as the Km you are going to get here. But the Vmax you got here will not be the same as the Vmax. So this one you are going to have Vmax inhibition. Now, let me now talk about the differences that you have in each of these things. For this case, for the competitive where Km is different, where the Km that you have for this line is different from the Km you have for this line. So the point there is that the Km you have here will be more than the Km you have here. And that's because in a competitive inhibition, the affinity of the enzyme for the substrate decreases due to the presence of the inhibitor. So that means that your Km that you have here will be what? Will be what's it called now? Will be more than this normal Km. So therefore, Km high, that is the Km that you got from this line, you are going to get a Km for this line, you are going to get a Km for this line, will be equals to Km, the normal Km for no inhibition, into bracket 1 plus high over Ki. So where Ki is the inhibitor distribution constant, while high is the what? Is the concentration of the inhibitor that was used in the what? In the reaction. So the difference between your Km high and this normal Km, this one for no inhibition and the one for inhibition, is what? Is this factor. This is the difference between them. So in a way, if you know the Km for this first line, for this line, and you know the Km for this other line, you can easily, and at the same time, they have given you the concentration of the inhibitor. You can easily get your what? Your Ki using this word, using this expression. Now, let me talk about the what's it called now? For the non-competitive inhibition, whereby you are having different Vmax, whereby you are having different Vmax. So in a way, when you have inhibitor being involved in terms of non-competitive, whereby Km is the same, the Km for this line is the same thing for the Km you are going to get from this line, but the Vmax will be different. So what happens is that in the case of a non-competitive inhibitor, the Vmax will do what? We reduce compared to what you have before. So the Vmax would, that is the maximum velocity of the reaction will do what? Will certainly reduce. And that's what we have for a non-competitive inhibitor. So in this case, that implies that the Vmax I you are going to get here, that is the Vmax for this line, will be what? Will be less compared to the Vmax for this line. So the Vmax for this line, you are going to get it will be less compared to the Vmax in this line. So in a way, so the same thing, the factor still remains, this factor still remains between the two. So in this case now, for this particular one that we have here, for this one that we have here, our Vmax, so our Vmax I, that is the Vmax for this line that contains inhibitor, will be equals to the normal Vmax where you have no inhibitor over that will be 1 plus, and then we have what? I over Ki. That's still the same thing. So I, like I said, is the concentration of the inhibitor which is supposed to be given to you in the question. At the same time, this is your Vmax for this line that contains no inhibitor, and this Vmax is for the one that contains what? That contains inhibition. For the last one which we have in this case. Now for uncompetitive inhibition, normally, so I've said for competitive inhibition, the Km will do what? Km will increase by this factor. But in terms of what's it called now, in terms of a non-competitive inhibition, the Vmax will do what? Will reduce. The Vmax will reduce for a non-competitive inhibitor, but the Km will still be the same. But for this uncompetitive, both the Km and the Vmax will change. For the uncompetitive, both the Km and the Vmax will change. But the factor between the two of them still remains the same. So in this case also, the Vmax will reduce, but in this, at the same time, the Km also will reduce. So for an uncompetitive inhibitor, both the Km and the Vmax will reduce compared to the one that you have for no inhibition. So the Km you are going to get here for this line and the Vmax you are going to get from this line will be less, compared to the Km and Vmax you are going to get for this first line, which contains no inhibition. So in a way, you are going to have that, let me just write. So the Vmax here, so the Vmax here for inhibitor will be equals to Vmax for no inhibitor over 1 plus I over Ki. So that's how to work about that. So you can easily use this expression to get, so since you will have gotten the Vmax for this line, from this line, you have gotten the Vmax from this line at the same time. So you now use the two of them together with the concentration of inhibitor given to you to get the what? To get the Ki. So you can get the Vmax for this line that represents the reaction that contains inhibitor. You can also get the, so the difference between two is always by this factor. So when you know the inhibitor concentration, the Vmax for this one that has no inhibitor, the Vmax for this one that contains inhibitor, you can easily use that to get your what? Your Ki. And don't forget what I said, the Vmax here will reduce compared to the one that does not have inhibition. So the Vmax you're going to get from here will be less, while this one will be what? Will be more. The same thing with the Km. So in this case also, the Km for this particular case also, let me just write it here that the Km in this case for inhibitor will be equals to Km, the normal Km, over 1 plus 1 I over Ki. So you can see that the difference between each of those parameters in terms of the reaction that contains inhibitor and the one that does not contain inhibitor remains the same, which is always 1 plus I over Ki. But now what happens to Km and Vmax in each of these type of inhibition differs? I said here you have the same Vmax, different Km, and the Km in this case increases. But for the sake of uncompetitive inhibition, both the Vmax and the what? And the Km decreases in the case of an uncompetitive inhibitor, but the factor still remains what? Still remains the same. And I also said about the graph that in the graph of an uncompetitive inhibitor, you are having the same slope, different y-intercept. So don't forget that. And the Vmax and the Km, both of them reduces. But for a non-competitive inhibition, the Km remains the same while the Vmax reduces. So, and that's why we have this expression. So anytime the parameter of the inhibition of the line that represents the inhibition increases with respect to the line that does not contain inhibition. So you multiply. That's why I have it. But in the other cases whereby those parameters are reducing, you can always divide. And that's why we are. So, but you can always use these expressions to get your what? To get your K high. And that's just how to work around for these three set of inhibitions that we have under reversible inhibitor. At the same time, how to get the parameters that pertains to each of them. So in case if they give you a question whereby they are asking you to try to bring out the type of inhibition that you have in a table of what? Of values or data from experiments, you can easily work around this. You can easily apply what I've said here to determine what type of inhibition that you have. But from the view of your graph, I've said if you have these two lines to be what? To have different slope, the same y-intercept, it is certainly a what? A competitive inhibition. And you can use this expression to get your Ki. This Km here is for this, is the Km you get for this line that has no inhibitor, and this Km here is for the Km you are going to get from this line that contains inhibitor. Now in this case that we talked about here, I said that for the case of an uncompetitive inhibition, you are having the graph will have the same slope but different y-intercept. This line and this line will have the same slope but different y-intercept. And I said you can either use either this expression or this expression to get your what? Your Ki, given that they have also given you the inhibitor concentration that was used for that particular experiment. And like I said, this Vmax here is the Vmax you get from this line, which has no inhibitor, while this Vmax here is the one you are going to get from this line that has inhibition. So the same thing, if you are going to pick your Km, the Km here will be for this one that has no inhibition, and this Km high will be for the Km you are going to get from this line that contains inhibition. And the same thing still applies here. So in the sake of for non-competitive inhibition, you are going to have a line with what? With different slope and different y intercept. At the same time, you can use the Vmax in this case to what? To get your what? Your Ki, because Km in this case is what? Is the same for where you have inhibition and where you don't have the inhibitor, and that's what shows the inhibition to be what? To be non-competitive. And I said that this Vmax here is the one that is from this line which contains no inhibition, while this Vmax I is for this one that is for this line that contains inhibition. And I've also tried to tell you what happens here. The Km increases here, both Vmax and Km decreases, and here the Vmax decreases. With all of this explanation, I believe you can work things out when question is given to you to apply all of these things that I've talked about. And I also want to refer you back to the previous video where I discussed how to get Km and Vmax from a line weavable plots, so that you can also have an idea on how to get the Km value for each of these lines that you have. At the same time, how to get how to get both the Km and the Vmax for each of these lines that you have. And you can now apply what I've discussed here to determine the type of inhibition, at the same time get the value of your Ki. I think with this short explanation, you have gained one or two things which will be helpful to you in tackling questions that they might probably give you on this aspect of enzymes kinetics. If you have questions or probably you have comments that you want to drop, you can drop it in the comment section. At the same time, you can try to contact me. And if you have any suggestion towards this YouTube channel, what we can do to become better and to make things much beneficial and interesting for every subscriber on this channel, you can also do well to drop that in the comment section. So I want to appreciate you for staying tuned and for watching this video. And please don't forget also to subscribe if you have not yet subscribed to this channel. Also, don't forget to share this video, this educative content with your colleagues who are probably in biological sciences or even in clinical sciences, who are offering biochemistry courses and might be in need of some of these educational content. And I hope it will be of great help to them. So once again, thank you for watching. Keep watching and don't forget to click the subscribe button. Thank you.